In this video, I'm going to go through a number of examples illustrating how to use the definition of logarithms to evaluate given logarithms. So, for instance, we want to evaluate log base 3 of 243 or log base 8 of 4. How do we do that? What we're going to do is use our equivalence between logarithmic form, it's on the left-hand side here, and exponential form on the right-hand side. Right? Remember the definition of logarithm. What does this symbol here mean? Log base b of u. Log base b of some number. That just means you're looking for the number that when you raise b up to that exponent, you get what's inside. Okay, so if we're calling that, say, v, then that's equivalent to saying b, the base raised up to that exponent, gives us what's inside the logarithm, which we're calling u here. Okay, so I'm going to go over to scratch paper and we're going to work out this list of examples, computing them by hand using the definition. Okay, so for instance, for log base 3 of 243, if we don't know what it is, what we're going to say is let log base 3 of 243 equal some number. Call it, say, v, call it a variable, and then we're going to convert this to exponential form. The idea is to get rid of the log form. The log notation is kind of confusing to look at. Let's make it simpler on ourselves. Now, 243, it happens to be a power of 3, so this works out perfectly for us. It's 3 to the 5th power, so what do we conclude from there? If the bases are the same, the exponents have to be the same. So we must conclude that v must equal 5. Now what was v? We called that log base 3 of 243. So our conclusion is log base 3 of 243 is equal 5. That's the power you have to raise 3 up to get 243. All right, for the next one, we do a similar thing. For this, we have to remember that that whenever we see a logarithm and there's no base on it, it's assumed to be base 10. We're going to again say let log base 10, in this case of 10,000, equal v. That's equivalent to saying what power do we raise 10 up to get 10,000. Now rewrite 10,000 as a power of 10. I got 5 zeros, so it's 10 to the 5th power. So we conclude that v is equal 5. Okay, and once again, that just means for us that log base 10 of 10,000 is 5. Going down below to the next one, we're going to say let log base 2 of 1/8 equal v. That's equivalent to saying 2 to what power is 1/8. This one's a little trickier, but remember 8 is a power of 2. It's 2 to the 3rd power. And then remember your definition for negative exponent. You can bring it something from the bottom to the top if you keep the base and make the exponent negative. So our conclusion is that v must be negative 3. All right, so what does that mean? Log base 2 of 1/8 is negative 3. You can check that with your calculator. Take 2, raise it to the negative 3rd power, and you're going to get 1/8. Now, we'll get this next one, 6, log base 6 of 1 over the square root of 6. Again, we're going to call it something. We don't know what it is yet, so call it v. Give it a variable name. Then convert to exponential form. Whenever you're working with logarithms and square roots or nth roots, you're going to want to convert those to exponents because logarithms play nice with exponents. So we're going to rewrite this as 6 to the 1/2 power, the square root of 6. And then, like in the last example, to bring that base up, we have to make the exponent negative. So we conclude that our exponent is negative 1/2. V has to be negative 1/2, and therefore log base 6 of 1 over the square root of 6 is equal to negative 1/2. Okay. Now moving on, going to the next example on our list, it was log base 10 in this case of 10 times the square root of 10. So again, we do the same thing every time. We want to convert from logarithmic form to exponential form just to make it easier on ourselves. And then that's going to say what number do we raise 10 up to get 10 times the square root of 10. Like in the last example, we want to get rid of square roots, write them as exponents. 10 is just 10 to the 1st power. Square root of 10 is 10 to the 1/2 power. So we get, by adding our exponents, got the same base, multiply, we add the exponents, we get 10 to the 1/2 or 3/2 power. So v is 3/2 or 1.5. And that's what we include. Log base 10 of 10 radical 10 is 3.5. 3 over 2, excuse me. Remember, whenever you don't see a base on a logarithm, it's assumed to be base 10. This next one, once again, we want to call log base 8 of 4 something. Give it a name. We're calling it v. This one's going to be trickier than the other ones because if we think about this for a second and try to estimate what the number is, we want to know what power do we have to raise 8 up to get 4. Well, 8 to the first power is 8. 8 squared is 64. We're going the wrong way. So our exponent in this case is going to have to be less than 1. It's going to be hard to guess what this is, so you're going to need to convert to exponential form and then do some rearrangement. All right, so the idea for this one's going to be, let's make the bases on each side the same. Let's reduce the bases if we can. 2 and 4, or 8 and 4 are both powers of 2. So we can say 2 to the third power raised to the v power is equal 2 squared. Now on the left hand side we're going to multiply our exponents together. We've got a base raised to a power raised to another power. Then we get the bases to be the same. So we conclude that the exponents have to be the same, which means 3v equals 2. Solving for v, we get that v is 2/3. Okay, so what does that mean? That was our exponent. That's what our logarithm is equal to. Log base 8 of 4 is equal to 2/3. We can check this. Okay, what does that mean? Log base 8 of 4 is 2/3. It means 8 raised to the 2/3 power must be 4. By definition of a rational exponent, the denominator tells us to take the cube root of 8, and then the exponent, the numerator of the fraction up top tells us to square. Cube root of 8 is 2. 2 squared is 4. It works out. You can check it with a calculator if you want to also. All right, for the last one, again, this one's not going to be something simple. 36 to the first power is 36. 36 squared is not 216, so it's got to be between 2 and 3. Or 1 and 2, excuse me. So we're going to call log base 36 of 216 something, v, set to convert to exponential form, so 36 to the v power is 16. Rewriting each side as a power of 6. 36 is 6 squared, 216 is 6 cubed. Multiply your exponents there, you get 6 to the 2v power equals 6 to the third power. So our exponents must be the same. And we set 2v equal 3. To solve for v, it's a linear equation now. Divide by 2, and v is 3/2. So what do we conclude? Log base 36 of 216 is equal to 3/2. Now, just like in the last one, let's check this one out. This one's not quite as obvious. This is going to say 36 to the 3/2 power should be 216. Well, is it? 3/2 power means take the square root of 36, then cube it. Square root of 36 is 6. 6 cubed is 216. So it checks out.